Hello friends, so welcome to another video. So in this video we will be seeing information about software defined networking, which is also known as SDN. So let's first see what is software defined networking. So basically software defined networking is an approach to networking that uses software based controllers or application programming interfaces to communicate with underlying hardware infrastructure and to direct traffic on network. So as in this diagram we can see, so basically we are having a device which is known as the SDN controller, or which is also known as Smart Grid Controller Center, and that is getting connected to network devices. In the diagram we can show there is a switch 1, switch 2, switch 3, switch 4, and we are having host devices. The whatever is control traffic, that is shown as a dotted line in the green color, and whatever is data traffic, that is shown in the blue lines. So here what we can see is SDN controller is connected to all the physical devices, and it is basically kind of a controlling those networking devices configuration. So basically here what we are doing is we are having a centralized device which is SDN controller, and this device is basically using software commands or softwares to control the networking configuration. Now, basically, SDN model differs from the traditional network. Traditional network uses a hardware devices. So, as we are aware, in traditional network, we will have routers, switches, and basically these devices have standalone configurations, and these devices will be controlling network traffic. SDN can create and it can basically control the virtual network, and or it can control the traditional hardware via softwares. So basically SDN will have a major role played by software. So there is another concept which is known as a network virtualization. So basically what network virtualization does is it will allow organizations to segment different virtual networks within a single physical network, or it can allow different devices to connect different physical networks to create a single virtual network. So that is a network virtualization. Now software defined networking, it will be enabling us to control the routing of data packets through a centralized server. So basically suppose if you want to send data from some of the devices to other devices, and using softwares we can define the network routes for the data transfer. Now here we can see that the difference which is there between the traditional network architecture and SDN architecture. So here first of all we can see in the traditional network architecture there is a distributed control plane. Control plane is kind of a concept on on network devices where the data traffic control decisions are taken, and data plane is basically a segment of the device where the actual data resides, and then we are having applications which can connect to individual devices, and it can basically we so whenever we want to configure anything on the devices, right, we can connect remotely to the devices, we can configure the policies, and the configuration can be done. However, for such thing to do, we will need to connect each device individually, and the configuration needs to be standalone. Now here, if we see the SDN architecture, we can see that there is a centralized control plane presence here, and we are only connecting to single control plane device which is a controller, and that controller is communicating with all the other network devices. So basically this is a difference. So single controller is pushing configurations to all the network devices. This allows us to have greater visibility of the network configurations, and it is kind of a single point of operation through which the network routes etc. can be defined. And this was not possible in the traditional network architecture, because there we had control planes residing on each devices separately, and due to the separation we would need to do the individual configuration on all the devices. Now let us see why software defined networking is important. So first important reason is that it provides us the increased control with greater speed and flexibility. Now, as we had seen in the previous diagram, in the traditional network, we need to do the manual programming. And what will happen is in the network, generally there will be multiple vendor devices. So vendors could be like Cisco, there could be Juniper, there could be Huawei, and each of those will have individual configurations required. So that will be taking a greater time to do that configuration. Now, what SDN allows us, like instead of manually programming the multiple vendor specific hardware devices, now developers can control the flow of traffic over a network simply programming a single device, which is a standard software based controller device. So this will allow us a great speed to do the configurations, and it will also allow us to have a flexibility. That is first reason why SDN is important. Another reason is customizable network infrastructure. Now, with software defined network, administrators can configure network services and they can allocate virtual resources to change the network infrastructure in real time through the centralized location. This allows network administrator to optimize the flow of data through the network and prioritize applications that require more availability. So sometimes what happens is, suppose there is a certain network link which is only having the traffic load at certain duration of time, right? So in such scenarios it is not feasible to have that link capacity increased at runtime because it will need a physical hardware allocation, right? However, using the software defined networking, administrators can configure network service and they can allocate a virtual resources so that they can allocate a higher bandwidth on that route for a certain duration of time based on the observations. And this can be done through centralized location via controller device. So that is the reason it will be allowing us to customize the network infrastructure as per the need. Next reason is to have a robust security. Now, software-defined network, it delivers visibility into entire network, and this helps in providing a more holistic view of security threats. So basically, what will happen is that as we're having a single control plane, an administrator can have the visibility of entire routes which are spreading over the network. Due to that, it can have a more visibility of network and it will give a more clear view of security threats. Now, with the increase of smart devices that connects to internet, SDN will offer a great advantage over a traditional networking. Also, operators can create separate zones for devices that require different level of security or immediately quarantine compromised devices so that they cannot infect the rest of the network. Now, contrary to the traditional network where operate operators have to connect to each individual device separately so that they can configure the control plane or they can basically have the customizations pushed to the devices using SDN. As there is a single point of contact which is controller and that device is controlling configurations of all the network devices, what will happen is operators or administrators will have a flexibility and they can directly connect to the different level of security devices and they can create a separate zones for suppose certain device requires a higher level of security. If it is a banking application or a banking server, then they can configure additional policies for such devices. And suppose if they see some kind of a virus attack or some kind of threat attack on network, it's possible to configure at a software level, uh, so they can basically quarantine the infected device or compromised device immediately so that it doesn't infect the rest of the network. Now, The key difference between SDN and traditional networking is infrastructure. So SDN, as name itself suggests, it is a software based approach, while traditional network is a hardware based approach. Now, as the SDN is a software based approach, the control plane, which is software based, it provides more flexibility than traditional networking scenarios. Now, SDN allows administrators to control the network. It allows administrators to change configuration settings, provision resources, increase network capacity, and this all can be done from a centralized user interface without need for more hardware. So basically, what will happen is, as there is a single point of contact device, which is a controller device, administrator can control the entire network, and it can change configuration settings, etc., directly by a controller device, and it allows or gives the administrator great flexibility. Now, also there are some security differences between SDN and traditional networking. Now, as we are having greater visibility and also there will be ability to define secure pathways, SDN will be secure than traditional network in a many ways. Now, here one point needs to be noted that as software defined networks use a centralized controller, so basically that controller device will have all the configurations and it will have basically a great control over the network traffic, etc. So it is very crucial to secure the controller device so that secure network can be done, because if the controller itself gets compromised, then it can put entire network or the network routes into great danger basically. So that would need to be taken care by administrators. Now here, this is a basic diagram related to the SDN operations. So here first layer we can see that there is a service layer. Now in service layer we're having various domains, like we can see there is a public safety. So whatever we're having as a networking uh, institutions or basically organizations, etc., that will be connecting to the network. Then we're having intelligent transport, like on the way when we connect to the network. Then there's the smart homes concept. Now if we have the washing machines or refrigerators which connect to the internet, then that will be smart homes. And then IoT service developers, so internet of things devices, right? So those kind of devices will connect to the network. Now these devices will connect to the network and they will be computing network. That network will be of SDN controller devices. Now another layer is a communication layer. So communication layer is the actual physical network which is laid by the telecom service providers, and we can see that SDN controllers connect to the devices such as gateways or router devices. Then these routers will have physical connections between each other. However, the configurations of those paths will be decided by controllers. We again can see data processing and storage centers where the, like Google data center or anything of that, for example. So that will be data processing and storage centers. Then we have devices layer, like our mobile phones, laptops, and everything is a device layer basically. So what will happen is, from the computing layer, the controllers will be getting information from the service layer, and based on that they will, or based on the service load, they will push the configurations to communication layer. So suppose if there is a great demand of bandwidth for a certain link, and it is coming from IoT developers, so based on the predefined approaches, SDN controllers will change the configurations based on the need for the physical network, and that will allow the fulfillment of the requirement of the IoT service developers team. So this is kind of one of the example where SDN comes into the picture. Now let's see how software defined networking works basically. So let's see the some basics first. Now in SDN, as it is again kind of a software defined thing, anything which is virtualized, the software is decoupled from the hardware basically. Now SDN moves the control plane that determines where to send traffic to software and leaves data plane that actually forward the traffic in the hardware. So basically in the traditional networking, there are two types of planes, or we can say separations, which are there on the devices. So whenever any data needs to be sent via network, there will be one layer of the intelligence which will be residing in the control plane. Now this control plane will actually take a decision regarding the routing, like where to send a traffic, what route to be taken, like what are the alternate path, etc. So that is known as a control plane. And data plane is a kind of a segment which actually holds the data. So suppose if somebody is transmitting a certain image or a voice note to over a network, then the actual content of the image or content of the voice will be held in the data plane, and the logic of the transmission that will be decided in the control plane. Now in what happens in SDN is that data plane is kept on the physical devices. However, the control plane, which actually takes the decision of the traffic routing, that is moved to the software level, and that is a kind of a centralized software basically. Now due to this, it allows network administrators to use software defined networking to program and control the entire network via single pane of glass instead on a device by device basis. So as we have seen in previous diagrams, controller will be having connection to all the physical devices, and as the controller is having the control plane configuration control, administrator can simply connect to the controller devices, and as per the need, the entire network routing decisions can be taken via the controller. Now here again we can see in the diagram, so we are having application layer, and then there is a control layer, and between the application layer and controller we are having the APIs using which the data transmission happens between application layer and control layer. Control layer will be using a proprietary protocol, which is the open flow protocol. Using that protocol, it will connect to the infrastructure layer, and it will push all the required configurations to the infrastructure layer. And the communication between control layer and infrastructure layer will be happening using a protocol known as the open flow protocol, as we had seen in the previous diagrams. Now, basically, if we see the parts of the typical SDN architecture, and all of these parts can be located in the different locations. So first important part is the applications. Now application is basically those will be communicating resource request or information about the network as a whole. So if somebody wants to use the controller or somebody wants to get the information, that will need to be taken via the applications. Another part is the controllers. Now controllers is basically an intelligent layer which will be taking information from the applications, and it will decide how to route the data traffic. So controller will actually take a routing decisions in SDN. And then the important layer is the networking devices. Now networking devices are actual physical layer devices, and those devices receive information from the controller about where to move the data, right? So basically applications will send the data, and they will send the resource request to controllers. Controllers will have the information, they will information from application, then they will decide how to route the data packet, and networking devices will get instructions from the controller, and based on that they will do the data movement actually in the network via physical layer. So this is a high level mechanism of how SDN works. Now physical or virtual networking devices will be actually moving data through the network, right? Because if the data transfer needs to be done at some physical level, there should be devices present, right? Not everything could be virtual, so at least there should be some physical layer. Now in some cases there could be virtual switches. Now those could be actually part of the software, or those could be hardware, and those can take responsibilities of the physical switches. Those virtual switches can consolidate the functions into a single intelligent switch. Now this intelligent switch can check the integrity of both the data and packet, and their virtual machine destinations, and they can move the packets along. So generally the data movement and packet checking is done by the router device which connects to the multiple networks. However, the intelligent switches can take the router functionality and they can route the packets through the network. Now, as we had seen in previous slides, there is a protocol which is known as the open flow protocol, and that protocol is used in the SDN architecture. Now, open flow protocol is a standard in a software defined networking architecture. This protocol will be defining the communication between an SDN controller and the network device agent. So as we had seen in the previous slides, if I go back to the previous slide, then we can see there that OpenFlow was being used for the communication between network devices and the controller device. Now, this protocol was first developed at 2008 uh, at Stanford University, and it was adapted by Google in their backbone network. Now it is managed by Open Networking Foundations, and latest version used industry is around 1.5. Now OpenFlow is a standard southbound protocol and that is used between SDN device controller and the switch devices in the network. Now SDN controller, what it will do, it will take the information from applications, it can convert it into the OpenFlow entries which are fed to switch via OpenFlow protocol. Now this can also be used for monitoring switch and port statistics in a network management. Now one thing which we need to note here is OpenFlow protocol is only established between a controller and the switch. It does not affect the rest of the network. So if a packet capture is taken between the switches and a network, both connected to the controller via another port, the packet capture would not reveal any of the OpenFlow messages between the switches. So basically OpenFlow is only used between switch and the controller. Networking devices like switches or routers, they will not communicate with each other using the OpenFlow protocol. So these are some of the basics of the OpenFlow which are used in the SDN. Now here we can see again another example of the SDN architecture. So we can see there is an application plane which is having the SDN services. So basically there is a interface which is known as ACPI, which is Application Controller Plane Interface. So that what it does is it allows basically to communicate applications with the controller's devices. Now we can see controller plane which is having controller devices, and these controllers will having the logic for service invocation and control. Now there is a data controller plane interface using which the controller devices will communicate with the physical network. Now we have actual data plane where physical or virtual service related network resources are residing, and these will be actual network and those will be used for actual transmission of data. And we can see their OFP, which is open flow protocol. So SDN communicates with SDN controller communicates with these network devices using open flow protocol. So this is how the operations of the software defined controller and software layer of the routers will be communicating with each other. So okay, now let us see what are the different models of the SDN. Now on a major level, the software controlling the flow of data in switches and routers applies to, it will apply to all the software defined networking levels. However, there are some different models of SDN also, though the basic principle remains same. So there is first model which is known as Open SDN. So network administrators can use protocols like OpenFlow to control the behavior of virtual and physical switches at the data plane level. So like we seen in the previous slide or previous diagram, the OpenFlow protocol is used in the OpenSDN type of the SDN. Now another way or another type is SDN by APIs. Now we could see that in the SDN by APIs, instead of using an open protocol application programming, there will be some APIs which will be controlling how data moves through the network on each devices. So basically what will happen is controller will communicate with those APIs, and the decision will be taken by the APIs regarding the route of the data on the network. So that is a second type of SDN network, which is known as SDN by APIs. Now let us see the next SDN overlay model. Now another type of SDN network is which basically runs a virtual network on top of the existing hardware infrastructure. Now what it does is it will be creating dynamic tunnels to different on-premise and remote data centers. Then there will be virtual network which will allocate bandwidth over a variety of channels, and this will also assign devices to each channel, leaving the physical network untouched. So what will happen is in this kind of a network, so basically SDN is not actually changing the configurations, but what it will have is it will create its own virtual network on top of an existing hardware infrastructure, and through those virtual layer it will create the kind of a virtual private tunnels or kind of a safe passages for the data, and only on the virtual level the policies or routing policies will be configured, and those will be synced with the physical devices. However, it will not affect physical devices at any level, it will just stay at the virtual level, and the data transmission will be used via the secure tunnels or the virtual private networks. So this is another type of the software defined networking which could be considered. Now another type is a hybrid SDN. Now as name itself suggests, this will be combining the multiple modes within each other. So this model combines software defined networking with traditional networking protocols in one environment to support different functions on the network. So like standard networking protocols will continue to direct some traffic, while SDN will take the responsibility of the other traffic. And basically this allows network administrators to introduce SDN into stages to a legacy environment. Sometimes networks are very huge and it is not possible to replace entire network at once. So in such places, hybrid SDN can be uh, used. So what it will do is it will basically live on the infrastructure, and there will be some traditional protocols like BGP, OSPF. These protocols are used for the traditional data transfer over the network. Now what hybrid SDN will do, some type of the data will be forwarded by the traditional routing protocols, and some type of the traffic will be handled by the software defined networking standards. So basically this is the hybrid SDN mechanism where the multiple types of the data transmission techniques are used. So it is known as a hybrid SDN. Now let us see how SDN can change the game. So SDN is a game changer for network players because it will enable programmable networks. It also will give a centralized intelligence. It will control the network, and it will facilitate the network interaction via APIs. Also, it can provide vendor neutral open architectures. So these are the benefits of the SDN. Now let us see what is programmable networks. Now as we can see, SDN controller is a software level application which handles the control plane data. Now the ability to control the network behavior using software external to the physical networking devices, that will give us an easy way to customize network in support of new services. Now basically softwares are very customizable as compared to the physical hardware devices, right? Now SDN, as it has a software, it gives us a flexibility to customize the network to support any kind of new services which might get introduced, right? Suppose if I have hardware device and if it is having a fixed capacity, if it is having fixed kind of a protocols, right, then it is difficult to go and change that hardware device in a quick way. However, if it is a software using which I am allocating the RAM, if I am allocating the disk space, if I am allocating the bandwidth, these kind of features, right? So it's easy to allocate these kind of resources via software Like as we see sometimes if we create virtual machines, right, it is very easy to create a virtual machine, right? And at a runtime, suppose if we need some large resources, then also it is very easy to create or allocate the resources. If we compare that to changing configurations of the physical device, we can understand the time difference which takes to update the physical configurations, right? So that is the difference basically, and this is the benefit of the SDN. Now we can do such functionalities at the granular level of the individual customer. So suppose only single customer wants certain kind of a data to be improved or certain policies to be improved, then that can be done using the software defined networking. Yeah. Now as SDN provides us the central control intelligence, it will allow us to do the bandwidth management, it will allow us to do the restorations, security and policies. So all of this will be highly optimized. So due to this we can get the holistic view of the network. Now this logically centralized network approach will allow us to manage the network in an intelligent way. Now we won't need to have a distributed control methods that result in the device operating with little awareness of the current state of the overall network. So as we had seen in a traditional mode, the control planes were residing on each devices separately, and those devices would be having only information about their configurations, and the overall state of the network will not be visible to a single device. However, in case of SDN, as we're having a software controller and kind of a centralized controller, and as it is everything at the software level, it is easy for controller device to have entire visibility of the network. So suppose if there is any congestion in the network, or if there is any kind of a threat in the network, it will be very easily visible to the controller devices, and the kind of a corrective actions can be taken by the controller device. So this is one of the benefit of the uh, software defined networking devices, as it provides us the centralized control. Now also it provides us the network interaction via APIs. Now here in SDN, our services and applications are logically separated from physical network hardware and connections, as we're having the controller level separate, and each device control plane is controlled by the controller at a centralized location. So instead of using physical connections and management interfaces that are tightly coupled with the hardware, our applications connect over the network infrastructure flexibly with the use of APIs between OSs, BSS, orchestrations, and occurrence systems. Now, as the control planes are not tightly bound with the devices in SDN or hardware component of the devices, it allows us to use connections or network infrastructure flexibly with the use of the APIs. So multiple APIs will be developed as per the need, and using those APIs we can have the flexibility of interaction via software component. So this is how SDN will allow us more flexibility in connecting to the devices rather than having a physical link to the network and basically kind of using a only some type of protocol to connect to the devices and only some kind of a application or some kind of a commands to connect to the devices. All of these can be replaced by more flexible ways using APIs, which can be developed by operation support systems or business support systems, right? So this is one of the other benefit of the SDN. So this is the way SDN will be working basically. Also, it allows us to have a vendor neutral architectures. Now, as the control plane is at a separate level, basically each hardware device will have a capacity to come to connect with the controller devices. So no matter what is a vendor, basically that vendor has to support the functionality so that it can communicate to the controller. So this is one of the benefit of the SDN, as it provides the interoperability and openness in the operations. Now multi-vendor Interoperability foster a vendor neutral ecosystem. Now use of an open API enables us to use of multiple applications such as cloud orchestration, software as a service, or business critical network tabs. Also, intelligent SDN software can control hardware from disparate vendors that utilize open programmatic interfaces such as OpenFlow. As we had seen in previous slides, OpenFlow is a protocol which is used by controller to communicate with underlying network devices. Now, each vendor which wants to be part of the SDN has to support the OpenFlow basically. So that will kind of bring all the uh, device vendors on a single line, and it will basically allow SDN software to control the hardware in a more effective way. So this will allow us to have the common IT software environment in an intelligent way, and this will improve the performance and the flexibility of the network in a greater way. So these are few of the benefits which will be part of the SDN, and it will help in more efficient network operations. So friend, this was the basic information regarding SDN operations. Hope you liked this video. And if you like this video, please subscribe to my channel. I will be creating more such videos. Thank you.